Hello, everyone, and welcome back. This is our next session in this series of building a GenAI application with AWS Bedrock. So we have been playing around with it. We've been playing around with Photo 3, making the connections, going back and forth. Now we are going to deploy the very first version of the application. So we're going to set the foundation of everything that we're going to be doing today. One of the things that we're going to do is we're going to start with a Lambda function and then a API gateway. That's where we're going to start today. Okay. So we're going to start in that part. We're going to be using AWS CDK with Python. So we keep all the language the same. We are going to go from here. We're going to build it. So we're gonna set up a API gateway, then we're gonna set up a Lambda function, and what we're gonna do right now is just simply being able to communicate through API gateway to the Lambda, and the Lambda being able to send communication over to Bedrock, and then receive the response and make it all the way back to the app to the API call that we make, right? So we're gonna be using that. This is gonna be simple enough for now, but then you'll see that with the Lambda we can make quite a few things to make things a little bit more complex, be able to take more things. And that's going to be the base. Then in our next sessions, we're going to be starting to build on top of that. Okay. So without further ado, let's share screen. Let's continue because we are going to create the folder, the structure. We're going to use AWS CDK. If this is the first time that you've been playing with AWS CDK, we're going to be talking about some of the basics of it. And there is a lot behind it, but we're going to be talking about our basic here. Okay. So this is you have seen this repo from the past. What we're going to do now in here is that we are going to create a new folder. Okay, let's create a new folder. And this new folder is going to have our app. So far in everything else that we have been using, everything else that we've been using has been kind of like ad hoc. Maybe I'll move things around a little bit after, but for now, I'm going to create a folder. It's going to be app, GenAI app. Let's call it GenAI app. GenAI app. We're going to do the backend. Okay. At some point, we may build a front end, which is going to be a little bit simpler. But for now, let's do a GenAI app backend. And so we're going to create a folder. Perfect. We're going to go inside this folder, and it's empty right now. And that's okay, because what we're going to do now is we are going to basically create. We're going to use AWS CDK. If you haven't used AWS CDK before, or this is the first time, I'm going to put the link on the AWS documentation and GitHub repository so that you can take a look at that and be able to install it, because you need to install CDK globally or with a node. So if you have never installed it, it will be IG AWS CDK. That will install the required files. And then for us right now, so I have already installed that. I have already run that command, npm i-g aws-cdk. I already run that. That's installed. So the next thing that I need to do is I'm going to install the CDK init. As you can see, I'm copying this from the documentation. So I'm going to do a CDK init GenAI app, or I can do GenAI backend. Why not? GenAI backend to differentiate a little bit, GenAI backend. Okay. And then the language, I'm going to do Python. But you saw like we can do TypeScript. You can go on Go if you want to, but for this case, we're going to do Python. So I'm going to go on to Python, and all right. So yes, this is not the okay. So we're going to do is init CDK init, and it should be just be app language Python. So it's going to go and create the application. So the app is not the name of the application per se, but it's going to be the what is it called? Just the template that it's going to use. So it's going to be generic app. So it's going to be the very basic. What it's going to do, you can see here, it's going to do create a virtual environment. Now it's going to take the name of the folder, and that's going to be the name of the app. So in my case, GenAI app backend, that's going to be the name that is going to go through for for the rest of the application. So my mistake, I always do that. I always think that the CDK init app, the app is the name of the application that I want to, like I was doing it before, GenAI app backend. No, it's always going to be CDK init app, that slash language equal Python. So my bad, I always get confused. Okay, so this will create our what is called our basic structure, and so you have your requirements. In this case, it's very basic requirements to begin with. The CDK, it's gonna have an app. This is the entry point. This is where everything is gonna start. And as you can see, we are referencing this library, which is the stack, and then it's calling that stack to be built. Now, what is that contain? Well, this is actually what it's going to contain. If you will see here, this is the folder by GenAI backend, which is this one, and then GenAI backend stack, which is this one, and then within that there is a class called GenAI app backend stack. So, and this is the GenAI backend stack. So, inside of this is where we will define all the different resources that we are going to build with this stack. And one of the things that we're going to do is actually we are going to separate these into multiple stacks. So not everything is going to be created at once. So right now we are going to start with the API gateway, and the first Lambda function, it's going to be in here just because it's simple. But as we build things, for example, our storage layer, that storage is going to be in its own stack. We are going to have a different folder so that we can deploy just that stack alone. If we have for example, a Bedrock agent, we will create a different stack for that. You don't have to, you can have everything in one file, but having it in different stacks allows you to be able to grow the application without having to be checking on every single resource every time that you want to deploy something, checking if something had changed or you need to deploy a change to that when normally you don't, you only do it on a few services. So that's why we will create multiple stacks. So if that doesn't make sense yet, don't worry, we're going to be making more. We're going to be growing this stack, CDK stack, and things are going to start clicking in as we move along. For now, all the code, all the resources that we're going to build for now, because it's going to be simple enough, are going to be in this stack, GenAI app backend stack. And what I mean by the resources, that is going to be our Lambda, our role, our API gateway, our routes, any configurations that we need to make, and so on and so forth. Okay? Now, what else has been created? Well, the other thing that has been created is the .vnv. And this is a virtual environment for Python. Now, do we need to use this one? In the previous videos, we've been using Conda or mini Conda. We do need to. The reason for that is because these virtual environments work a little bit different, and the CDK is leveraging the way that virtual environment work. If you try to use Conda and the CDK, it's going to give you issues. So what I found when I was doing this is that if I install the CDK, and you will see here, these requirements needs to be installed so Python can convert from CDK to CloudFormation. If you do it in Conda, when you run the commands for CDK, it's not going to find it. It's going to tell you, hey, I don't know, you don't have CDK installed. You don't have the AWS CDK live installed. That's because of how it works. But if you use the virtual environment, it will be fine. So to avoid any possible issues with installation of packages or anything else, we will be using the virtual environment that the CDK has created for us. Okay, so if you have catch that, there is two parts of the CDK. One part is a global that it's based on Node.js and there is nothing you can do about it. You really don't interact with that part much. That is just kind of like the interpreter of everything to convert from Python to CloudFormation. And then there is the AWS CDK lib, which is the package inside Python that will understand the different services available to us and that will allow us to build our stack. And so that is particular to Python. The other one is not. The one that we will interact the most is going to be within this, which is Python. So those are the two parts. If they are not aligned, you will get issues. And that's why we're going to be using the virtual environment instead of Conda so that we avoid any possible issues in building our stack. So how do we initiate our virtual environment? Well, we're going to do source virtual environment being active. Now, active, this one is good for Bash. You will see here that there are others like Fish. If you are running a terminal in Fish, you will be able to activate that. If it's Windows, you will be able to activate it with the .bak, I believe, file, and then you will be able to use the same virtual environment, okay? Now, in this case, you will see here, this is my virtual environment on the left. I do have the Conda base here. So which one am I actually, so this is the virtual environment, this is the base. Which one am I actually using? Well, I can go and say which Python, and you can see here, it's telling me that I'm using my virtual environment because that is the VNV. So now I'm good. What I'm going to do next is I'm going to install my requirements. So install -r requirements.txt. And what it does is the pip will go read this requirements file, and it's going to install those packages. So it's going to go, I'm going to do this. We're waiting for all of this to finish. And we should be good to go. Okay, just finishing here. Perfect. All right, so everything is good there. And we are good to go. What are we going to do next? Well, we're going to start building our stack. And so where are we going to build our stack? Well, remember, we were talking about in here, this is virtual, we close that. So this is the app, this is the entry point. And so it's going to run these, but this is actually coming from the GenAI app back stack. So what we're going to do is we're going to go here to my app stack, and then I'm going to go and we're going to start building. So the first thing that we're going to do is going to deploy our Lambda function. Let's say we can deploy our Lambda function. Where can we get the definition of that? Well, it's very easy. Let me change my screen so we can see the whole thing instead of just this, instead of just my Visual Studio. All right, so this is my whole thing here. So as you can see here, this is the AWS definition. You see it for .NET, Go, Java, Python, and TypeScript. All right, we are interested in Python. So I'm going to click on Python, and off it goes. This is the location or the definition that we're going to be using for our Lambda. So there is a few things that we need to do. Okay, let's start with this. So I'm just going to copy this, but before we do that, we need to import our Lambda. We need to import the library that has Lambda. Okay. Funny thing with Lambda is that the word Lambda in Python does have a meaning. You can define a Lambda function, which is completely different from AWS. Lambda has a completely different meaning. So because of that, it's important for us to ensure that that we are defining these. I'm just going to go here. That we're defining this properly. So if I do here AWS CDK import Lambda, we're going to do AWS Lambda, and we're going to import it as _Lambda. That is just make it easy instead of having to write AWS Lambda all the time. Although if you want to, you can just leave it as AWS Lambda. Okay, so I'm going to copy this. This is my Lambda. Okay, so this is my Lambda function here. Just, it's a little bit different because I imported with an underscore to begin with. You know what? I'm going to do Lambda underscore like this. And just because I don't like the underscore at the beginning of the package name. Okay. The other thing that we need to do is, it's struck. That's good. Okay. We may need to install another because I always get this. We may need to install the construct here, but we'll get it that in a moment. Okay. So Lambda function self, let's call my function. So I like to call always this one the orchestration function. You can call it anything that you want to, but because it's the first one, it's going to orchestrate a lot of your input. You don't have to call it orchestration. You can call it anything you want to. Other names can be input handler, or what is it called? API handler. I mean, there is not really any hard definition on how you should call it. But for me, I always like to call it orchestration. Just because it's going to orchestrate a lot of the activity that is going to go with my application. Okay. So my runtime is lambda underscore dot runtime. And here you saw that I had Node.js. That was what I had before. But really what I want is actually Python. So I'm going to do Python 312. Now I need to double check if that is the correct value for that. The next thing that we're going to have is the handler. The handler is how it's going to access the function. So the first thing is going to be that it's going to be index. That's the name of the file. And the handler is the name of the method or function inside the code. So, what I'm going to do next is also I'm going to create a new file where I am actually going to put the actual code itself. So I'm going to do lambda, sorry, not like up the letters, lambda. And here in my lambda, I'm going to do another folder, which is going to be my orchestration. And then inside my orchestration, I'm going to do index.py. So what does that mean is that, okay, this is my, what's it called, my file, which is index. And inside this, I'm going to have handler call, a function called handler, which is going to be my index.py. Okay. Just a quick second. Okay, perfect. All right. So now that we have all of these, we need to modify the code so that we can actually reference this file that we have. I don't have anything on the file yet, and that's something that we need to define. Let's make sure that our Lambda function is able to connect and do what it needs to do. Okay. So the next thing, okay, we are going to change something here. We're going to go instead of this line of code here, which is path.join directory name lambda handler, what we're going to do is from this asset, we are going to say, okay, you know what? From the asset, what I want is my Lambda, which is my Lambda folder that I created. And inside this is going to be my orchestrator. I cannot type. I never able to type on camera. So we have that Lambda orchestrator. My runtime is good. My index is good. This is good. I just need to remove one extra uh, bracket here. And now there is going to be a few other things that I want to make sure that we have. So the first one is going to be my time out. So this is going to be how long do I want my maximum duration of the Lambda? I'm going to leave it at 5 minutes, although that's quite long for what we're going to be doing. Maybe I'll reduce it. Maybe this is going to be just 45 seconds. This is in seconds. Okay, fantastic. The next thing that I need to, the memory size, I'm going to do it at 128. Really doesn't require a lot of memory. Even then, maybe it's a little bit too much, but 128 should be fine. The next thing that I'm going to need is my role. Now, you really have not seen the role. We haven't refined a role, so why don't we do that? Because we do need a role in order for Lambda to be able to access Bedrock, to have that functionality. And that role, we are going to be able to expand it even more and more as we go through the expansion of the application. We're going to add more permissions, and why not? The first thing that we need to do is we are going to need to define the role here. For that, we are going to be using another AWS service, which is the IAM. Okay, so the IAM is what we're going to use here. So the first thing that I need to do is I'm going to bring it with me, AWS IAM. as I am. Perfect. And then the next thing that I'm going to do is I'm going to define my function here. And so I'm going to do lambda retrieval role. Okay. So as you can see, this is auto-generated because I have Amazon Q installed. So Amazon Q is helping me build this code. So I'm going to go and accept the code, and I'm just going to double check that what it's doing is correct. So it's assumed by Lambda, correct? That's what I want, my service principal to be Lambda. Good on that end. Then my manage policies, it's a basic execution which allows it to send data to uh, CloudWatch. So that's what basic execution is. And the other one is the Amazon Lambda VPC execute. I really don't need a VPC access execution because I'm not attaching it to a Lambda function right now. So I actually going to delete this one because I don't need that one. Okay, so we have that. That's the manage policy that I want to attach for now. Let's add a description. Why not? Let's add a description. Role for Lambda retrieve. Role for Lambda to connect to Bedrock and in the invoke models. But right now we haven't defined access to Bedrock really. So what we're going to do next is we're going to define a policy, Bedrock policy statement, because we don't want to give it too much control. And so again, Amazon Q help me with this Amazon policy statement. And then my actions is going to be Amazon Bedrock. I'm going to do just an invoke model. That's what I want. And that's the action that I'm allowing it to do. Now, the fact is I'm allowing it, and the research, I'm going to leave it for everything. I'm going to leave it so we can invoke any model for now. Okay. Now, in your production environment, you may want to restrict it, but you don't have to. You can allow it to a model. The only thing that we're allowing it is to invoke that model. There is no other action that we are allowing it to do. Okay. Okay. So we have that, but now how do we attach this policy to the actual function? And the way that we are going to do that is by saying, okay, lambda retrieval role that add policy, perfect. I'm saying you did this correct, add policy, Bedrock policy statement. Awesome, we have that. And next, what we're going to do is lambda retrieval role. That's the role that I want in order to be able to be attached to this lambda function. Now, it's always useful if we want to use environment, but I don't really need the Bedrock environment, sorry, Bedrock region. What I want is a Bedrock model ID. And this is going to be what we had before in our other previous test. So this is going to be useful for us to be able to have done all these other tests before. And so we can actually get the model ID that we want to. In this case, I'm going to use Amazon Double-Light, but the system inference profile. I'm going to go here and I'm going to put it here. This will allow us to modify the model as we go along without modifying the code, sort of, because as you have seen before, if we change the model family from, like, for example, Nova to Claude, we do need to change the code so that the inference works properly. Okay. But for now, we have the model ID. We can change it from Nova Lite to Nova Pro or Nova Premier or Nova Micro without changing the code because we're doing it everything within the same family. So far, so good. We have our role, we have our function. Everything looks good. I think we're good to go to deploy our first application here. So what we're going to do is so something that I did there. I'm selecting an interpreter because it's telling me that AWS CDK could not be resolved and the constructs cannot be resolved. And that is because over here down below in my Visual Studio, I'm using this version of Python. And this version of Python is my base version from Mac. What I need to do is I'm going to change it. and I'm going to go with AWS GenAI app here down below. Awesome. Perfect. So now it's going to be able to check the actual libraries that I have installed. Now, because the libraries were not installed in the Conda environment, the libraries were installed in my virtual environment. Thank you for whoever said that caught that. It is installed in my virtual environment. So how we're going to do that, I'm going to go ahead and I'm going to take a look at my environment here, and it should be in here. Let's see here. If I remember how to, okay, perfect. This is my environment here. This is my bin. There is my Python. Select interpreter. Let's go with Python 3 here. Okay, so I have my interpreter here. Good. Did it select it? Why didn't select it? It went to Miniconda again instead of my interpreter here. Let's see if I can do this again. Enter interpreter path. We're gonna go one up. Okay. And this is bin, select interpreter. And let's go with Python. It should be there. Select interpreter. Okay. It just doesn't like it. Okay. So that's okay. That's okay because really, but this is not where we're gonna have the issues. The important thing is that over here in my terminal, I can do which Python, and that's giving me the virtual environment where I have my CDK deploy. Okay, so the first thing that I can do is CDK synth. So it's gonna go. This is a warning because I have the latest node is installed. So it's currently running bit 2310, which the CDK only supports 22. So one of the things that I like to do here is use NVM, use 22.11.0. NVM, if you have done install it, it allows you to use different node versions without too much issues. So now I have changed to that, and I can do CDK synth. And see, it was giving me an error. Let's take a look. So process exit with error. Cannot find asset lambda orchestrator. Oh, okay, so it's telling me that I cannot find this asset here. Where did it go? Now it can tell me that orchestrator. Did I spell something incorrectly? Orchestration. That's why. Cannot find it. Let me fix that. Orchestrator. Okay. So I fix that. Keep in mind the names have to match. And programming, you know what it should be. Okay, now everything is working. Awesome. Now, this is in region US West 2. Let's see, which one? Where is it deploying my function here? So I want to make sure that it's deploying it on US is 1. And maybe that is something that I need to define here. Okay. Pa, 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 pa. Okay. So everything is good. Everything is good. There is no errors. Everything is fine. Perfect. So I just want to make sure that I'm going to be deploying these on US East 1. And you can see here my environment here. I can define this environment in here. So I can uncomment that. It's going to use my default account, but the region is going to get it from this CDK default region. You can definitely leave it like this. In my case, I want to make sure that we are deploying to US East 1. And the reason for that is because there is going to be models also we're going to be used later on that are only available in US East 1, especially Canvas, Real, and Sonic. They're only available in East 1, and they have not system inference profile that allows to access them from other regions. So I don't want to deploy in US West 2 and have to destroy and then have to deploy in US East 1. And the reason why I know it will deploy to US West 2 is because my default region for my profile is US West 2. So to make sure that that's not the case, I'm going to change my region here in the app, and then that will force the stack to go into US East 1. So I did my CDK synth again. Synth is just verifying and converting, doing a conversion of my code into CloudFormation. So it's synthesizing the code, if I can pronounce that properly. That is what it's doing. Now, the next thing that I'm going to do is CDK deploy. Now, with CDK deploy, it's actually going to connect to my AWS account and it's going to deploy my code. So in this case, we can review what it's doing, the policy changes, the assume role, the Bedrock inbound model, and say, okay, you know what, that looks good. I'm going to go and say yes, and it's going to deploy. What is happening in the AWS account? Well, in the AWS account, it's actually creating a cloud formation, but no, it's creating a cloud formation at our end, in our local, but then it's sending, what is it called? Forgot the service right now. Shoot. Yeah, CloudFormation changed that. So it's in a CloudFormation. Yes, it's in a CloudFormation. Sorry, it has been a long day. It has so many names in my head. So it's connecting to CloudFormation. It's creating a stack in there and it's deploying the stack. That is what is going to be is syncing all the time. And that is what is happening right now. It's creating a CloudFormation chain set. It's deploying the stack. And if we want to, we can go to our AWS account and see that the stack has been deployed. Now, in this case, it's telling me that, hey, you know what? The file must be a non-empty C file. So guess what happened? Well, our Lambda function is completely empty. There is nothing in here. So we haven't done anything in here. So let's do something here really quick. Boto3, let's import Boto3. And then within Boto3, we're going to do define handler because this is what we CDK that this is the first function that we're going to initiate, right? We're going to initiate this function. Usually go and look for this function, initiate it, and execute this. So handler is going to be every Lambda function will receive an event and the context. Okay, context, and it's going to do this. Now, Amazon Q is giving me, hey, you should list all the buckets. No, that's not what I want. I'm just going to do something simple right now, which is I'm going to print the event. And that's it. That's all. That is just something to have so that we can deploy this properly. So I'm going to go ahead and I'm going to deploy again. Why it didn't give me this error when I synthesize the code? Well, because at that time, it actually doesn't try to zip the folder. It doesn't try to do any validation of that. That happens when the CloudFormation change set is actually executed. All of that is happening here. It's going. Now it's going to do the CloudFormation change set. It's not asking me if I want to, if it's okay to deploy because it already deployed the IAM role. And that's kind of like the security to say, yes, you want to deploy this IAM role or not. So we say yes, but now with the Lambda function, it's just going to go ahead and deploy the Lambda function itself. So it's going to deploy this, and we're going to wait a little bit for it to come back and tell us everything is good. What we're going to do next is we're going to add code that will allow us to create the Lambda function. To create to interact with bot. All right. Okay, so everything finished. It got this is the CloudFormation that got deployed. This is US East 1. That's my account. That's the stack name, and everything's good now. So that's looking good. Now, right now, really, if I were to execute this Lambda function, it wouldn't do anything. It will just print the event that we receive, and that's it. Nothing really useful. So what are we gonna do next? Remember the code that we were writing before? Now comes very handy. So let's do this. Let's go ahead and let's have the model ID already over there. So we're going to do client runtime. Actually, let me split this screen to make it easier. So what we're going to do is we are going to Bedrock runtime. Perfect. The system here. Perfect. You're a helpful assistant. You can change it if you would like to. And then the next thing is going to be the message. Message. Perfect. Now, if we leave the message like this, anything and every time it's gonna ask this, it's gonna run the same thing. It's not really going to change anything. But for now, that's okay. We are just gonna make sure that we're able to deploy this without any issues. And then I'm gonna copy all of this the same way. I'm going to copy this. Sorry, I'm just going to. Okay, perfect. Now here, the model ID is, we haven't defined the model ID itself. So where is that coming from? Well, that is coming from our environmental variables. And that's something that we define in our SDK, remember? So if I go back to my definition, here in my environment, I define my Bedrock model ID, and this is what the value is. Now I need to access this environment variable. So what I'm going to do is I'm going to do model ID equal os dot environ get model Bedrock model ID. Perfect. So it's going to get that model ID. Now, if I wanted to, I can put a default value here because it's a get. And I can say, you know what? If you cannot find the Bedrock model ID environmental variable, then just use this as a default. That is just to make sure that we are able to, there is no errors in doing this. Okay. So I have all of that is required for my converse. It's good to go. Now, the only thing that I need is being able to get the result. So to be able to get the result, I'm going to go ahead and I'm going to copy what we had before. Perfect. And I'm going to be with output. I'm going to save it in output equal. I'm going to save it here. Now, if I want to, I can print it. I'm going to go ahead and print it just for the sake of to make sure. And the other thing that I'm going to do is I'm going to return it. So I'm going to give it a status code 200, a body output. I'm not doing any checks right now. You should, and we are going to, but for now, this is going to be something very simple. I'm not doing any checks. I'm not going to need try it and catch. It's just, I'm keeping it as simple as possible so that we're able to test this and see that it's running or not. Okay. So everything is working here. In a moment, we are going to change the message. Instead of being this hard-coded, we're going to make it that is coming from the event. And so that we can actually pass some variables and that can change and react to what we want to. But for now, I'm going to go ahead and CDK deploy this again. Check that I didn't synthesize it first. And that's because you can see there is synthesized for me anyway when I did deploy. Okay. If you want to make sure that your code is passing minimum structural requirements, you can do the same before deploying it and then do the deploy afterwards. For now, we are doing the deploy at the same time. It's going to go ahead and update our Lambda function. So we are one step closer to our orchestration here. Perfect. It's almost done. Awesome. It's done. No issues. It's good to go. Now, how can we test this? How can we make sure that we are able to execute that is executing properly and that we are not getting any errors? Well, there are a few ways that you can do. The easiest one is if we log in into our AWS console, we go to the Lambda service, and then in the Lambda service, we are able to go into, don't forget, this is in North Virginia. So in the Lambda service, being able to go to the function itself. And that's what I have right here. Okay. Sorry, I didn't show you all the stuff because there is other stuff that I have going on in this account. So I want to make sure that I don't show things that I shouldn't be. Okay. So what's going on here? That's the code that we have. Look at that. It's beautiful. We didn't have to come into the console up to now to be able to deploy it. Now, if we take a look at our configuration, you will see here that this is the timeout that we set up, the memory. You can use ephemeral storage. We are not using that at all. And the other thing that we're doing is the permissions. Look at that. That's the permission. That's what we have selected. That's a CloudWatch logs. Remember what I said, the basic execution role that we attach to it? Well, that one is that. And our environmental variables. Look at that. That's the model ID and that's the value. Awesome. Now, how do we test it? We go to the test tab. You got it. Okay. So in here, right now, we are not sending any data through the event that is meaningful. It's not reading anything through the event itself. So what we're going to do is going to go and test it. And what it should do is should connect to Bedrock and it should give us an answer. And look at that. We do have an answer. Status code 200 in the heart of an ancient forest of Eldergrove. So it did go ahead and create a story for us. Woohoo! Yes, we have the first one. Okay, you have a Lambda, it's good. Do you want to do the next thing and make it a little bit more exciting and actually change it, the input, so it's not always giving you a story um, of a dragon? Okay, so let's do that. Let's go ahead and do that. Just a quick second here because my screen is doing something weird, but we should be good. Okay. So what are we gonna do? How we're gonna do the next part? Well, what is it that we are gonna be sending over to the event? Well, in the event, that is what we can pass up. Well, that is what we can send over to the Lambda function. And that event basically is a JSON. Okay. So let's go here in my index. And so this event here that I have here, this event is going to be a dictionary because when we send the code, it's going to be a JSON. And so it's going to be a dictionary. And so I can be, you know what? User prompt. And I'm going to be event.get. Let's call it prompt. Why not? So it's going to get that prompt. If it doesn't find the prompt in that JSON, then it's going to say, you know what? Write a short story about dragons. Sorry about that. So we're going to take that. And instead of this text, we're going to do this. That's all we need. Now we have made it a little bit more interactive. So remember, it's looking for a key called prompt so they can get the value of that key in the dictionary. If it cannot find that prompt, it's going to use this. That's as a fail safe. If we didn't have this, then it will be empty, and then the logic of the structure will fail. Okay. You can also do it with a try and catch, so that if you try it and it's a failure, you catch it and throw back a 500 or a 403, depending on what's the issue here. So we're gonna improve on this as we go along. But for now, we are getting this up and running. Okay. So what does that mean in our Lambda? Okay. We have this test. Beautiful. It has been updated. So if we go to the code, you can see here, let me refresh here because it didn't refresh from my UI. And so now look at that. That's the code that we just wrote. Okay. So we're going to go to the test. And in the test, we are going to do, you know what? I'm going to do prompt. What shall we ask it? You know what? We are just coming out of 3 weeks of Formula One. So I'm going to ask you something about Formula One. Explain Formula One to me. So very simple. You can ask many different things. And I'm going to go ahead and I'm going to click on save first. I'm going to give it name Bedrock test. I'm going to save it. So that's my test. And I'm going to go ahead and test it. Tell me the JSON syntax is not correct. And I'm going to test it. So it's running, it's running, it's running, and it came back. Look at that. Formula One, often referred to as F1, is the highest class. Great. Okay, shall we do a different one? Let's do how many planets are in the solar system. I'm gonna save it. I'm gonna test. Okay. There are 8 planets in the solar system. There are in other sun. Woohoo! We are able to interact with it without the UI. We are doing this in AWS. Okay, so what is the next step from here? Well, there is a few things that you can do with this. You can actually send a prompt directly from another application and send it over to Lambda. You can add API gateway on top of it. You can add the what is it called Lambda URI to it, so that you can hit the Lambda directly. So there is a couple of different options for you. What we're going to do next is we are going to create an API gateway in front of it so that we can interact with it from our local system and go and send an API gateway and go back and forth, go back and forth. But here's the thing. That's something that we can do, but can you think of any other code that you can add into your Lambda function to make it more useful? Well, probably you have a database, so you can access it through the data. You can access code. You can access the database through your code via SQL or Postgres and write a connection and retrieve certain things. Now, I wouldn't recommend just putting an API gateway on top of the Lambda and then leave it like that because API gateway is public. And so people will be able to interact with it. So make sure that what you're doing, it actually has a security environment. This is for demo purposes. We are going to build it and we're going to add security to it. But as it is right now, just a Lambda itself is secure because it's not connected to anything and we cannot hit it from the outside. You put an API gateway, all of a sudden the world can hit it and it can do a lot of different things. So make sure that if you put an API gateway, we secure it one way or another. So having said that, for now, we are good to go. We have deployed things. We have done our first deployment of the first version using Lambda. Super happy. Hope you enjoyed it because we are going to go to our next session. We're going to have an API gateway on top and we are going to be able to hit it from our end. This will allow us to interact with this service a little bit faster and don't have to come back here into the test and have to write this, but rather being able to use like something like Postman to be able to interact with it and to be able to see what's going on. All right? All right. So I hope you enjoy it. Keep playing with it. Maybe do a couple of other things. Maybe add things, a little bit of code to your Lambda function to do a little bit something extra. And yeah, let's keep having fun. Talk to you soon in our next session.